Alright, chapter 5-7 is actually pretty short. We're dealing in rational exponents, and basically all you need to really know is that a rational exponent is an exponent that is a fraction. And here's how it's going to be set up. A fractional exponent is determined this way. It is always the power over the root of the number. So if I gave you guys an example of this and said 81 to the 1/4 power. Take a second, just kind of examine 1/4 here. What that's saying is that we're taking 81 and we're raising it to the first power, and we're going to take the fourth root of that number as well. All right? And so whenever dealing with a fractional exponent, you always want to do the root first and then the power second. So we always say root down, then power up. Sounds like a strange line from Power Rangers or something like that, but it's not. It's really just a mathematical order that will make things a little easier for you. So when taking 81 to the 1/4 power, what we're doing is we're going to take the fourth root of 81. In this case, the fourth root of 81 is actually 3, and we're going to raise that to the first power. So your answer is just 3. All right? So let's do a few examples of that. If I give you, say, example number 2, this is example 1, so if I give you example 2 and said 32 to the 3/5 power, what we're going to do is we're going to take the 32 and bring it down to the fifth root. All right, the fifth root of 32 is 2, and we're going to raise that to the third power, which is 8, which is your final answer. Another example of this would be 36 to the 3/2 power. We're going to take the second root of 36, which is 6, and we're going to raise that to the third power, which is 2/16. Upping it a notch, if I say 49 to the -1/2 power, we're using a couple of rules here. Remember, any negative exponent flips, it inverts your number and throws it on bottom. And now all we're doing is taking 49 to the 1/2 power. Well, 49 to the root of 2 is the square root, which is 7. And let's take a look at one last one. If I say number 5, actually no, let's take a look at a couple more, sorry. The whole thing, 1/8 to the -1/3 power. So let's go ahead and invert the whole thing. So that's really 8/1 to the 1/3 power. Well, 1 to any type of root or power is going to be 1, so I don't need to be worried about that. That's gone. 8 to the 1/3 power is 2. All right, the third root of 8 is 2, to the first power is 1. Okay, one last one, sorry. 27 to the -4/3 power. So again, 1/27 to the 4/3. All right, 1/, well, the third root of 27 is 3, and we're going to take that to the 4th power, which is 1/81. Okay, let's take a look at some other versions of this. So when it comes to using rational exponents with variables, we basically apply the same rules as we did before. So if I say a to the 2/3 times a to the 5/3, we still have the same bases going on, so a is going to be my base, and then my exponents are simply going to add, so I get a to the 7/3. All right? Same thing here. If I say number 2, if I have x to the 1/2 times x to the 3/4 times x to the 1/5, well, I know that I have to have x as my base, but my exponents need to have a common denominator. So this actually becomes the hardest part of the problem. And I know that my common denominator is going to be 20. So this is really 10/20. This is really 15 over 20, and this is really 4 over 20. So what I end up getting is 29 over 20, and that is my answer. Whoops, reversed. Okay? The thing that I need you guys to really understand is how to rationalize denominators using rational exponents. So if, for example, I have, say, whoa, I don't know why it does that all the time. So if I have something, say, for example, like number 3, which is 1 over y to the 5/6, a rational exponent on bottom basically means that I have a radical on bottom. And remember from the last lesson, we can't have any radicals on the bottom. So I need to figure out a way to turn this 5/6 into a whole number. So what I'm going to do is I'm going to multiply the top and bottom by y to the 1/6 power. And what this does is I get y times y to the 1/6 times 1, which is y to the 1/6. And what I get here is y to the 5/6 plus 1/6. That makes that 6/6. So I get y to the first, and then y to the 1/6 up top. And that's how you rationalize denominators with all of this stuff. So if I take it one step further, if I say w to the negative 3/5 power, what that really is that is 1 over w to the 3/5. And I'm going to multiply both top and bottom by w to the 2/5. So 3 plus 2 gives me 5/5, so that's w below w to the 2/5 power. And a lot of times you might just see that in your homework. You'll just see this, and they'll say, okay, w to the negative 3/5, and then they'll expect you to do something with it. Make sure you guys know that they're just trying to get you to rationalize that denominator. If I have, say, a problem like xy to the negative 1 over 8, remember, the negative exponent only impacts the thing that it's making direct contact with. So what that is x over y to the 1/8. I'm going to multiply both top and bottom by y to the 7/8 because I want to create a whole exponent of 1 on bottom. And I get xy to the 7/8 up top. All right. So here comes some more rationalizing denominator stuff. And the next one is actually a little more involved, but it's still quite simple. If I say something like, I believe we're on number 7. If I say something like 1 over b to the 1/2 plus 1. This one's a binomial expression. It's a little more complicated, but again, we learned about multiplying by conjugates. So anytime you see this binomial expression, you just take the conjugate of it, which is b to the 1/2 minus 1. And what you get up top is pretty simple. It's b to the 1/2 minus 1 over, this is going to multiply in to give you b to the 2/2, which is b. And then these two are going to multiply together to get you minus 1. Now remember, in a conjugate, you don't need to do the inners or outers because you know they're going to cancel each other out. Number 8, if I say x to the 3/2 plus 3x to the negative 1/2 over x to the 1/2. Now please don't even think of moving this x to the negative 1/2 to the bottom, because this plus going on here, you cannot do that. What you want to do is you want to multiply both top and bottom by x to the 1/2. So the bottom part's actually easy, x to the 2/2, which is 1. The top is going to get the distributive property, so I get x to the 1/2 times x to the 3/2, that's x to the 4/2, which is x squared. This side is going to be 3. And then x to the negative 1/2 times x to the 1/2 is x to the 0, so that's 1. So 3 times 1 is 1. That means that that's as far as you go. All right, let's do another one. last example here, 2a to the 1/2 plus a to the 3/2. This is similar to the last problem here, over a to the 1/2. Okay, so again, just a to the 1/2, both top and bottom, you get a to the 1. This is going to get distributed in 2a to the 2/2, which is 2a, and then a to the 1/2 times a to the 3/2 is a to the 4/2, which is positive a squared. And actually from here, you can factor out an a to get 2 plus a over a, and you can cancel those out. Your final answer is 2 plus a. Okay, that just about does it for this lesson. We'll see you next time.